Good morning, afternoon, evening, guys. So today we'll be talking about integration, right? Specifically on one of the other methods of integration, all right? And this method in question is what we call as the u-substitution, all right? So what is this u-substitution method actually? It's a very common method, very well-known method actually, and this will be used in certain functions, all right? For example, um in composite functions, okay, composite functions, okay. So what do I mean by this composite functions? Okay, so say you have a function, okay, uh fx gx, okay, sorry, not fx gx, it's more like this. So a composite function by nature is f gx, okay. So the gx, so function gx is mapped into function f. Okay, it's mapped into function f. Okay, so that's what we call as a composite function. Okay, so when we take the derivative of a composite function, okay, in this case our f gx, okay, what do we end up having is we end up having a derivative of f derivative gx multiplied with the derivative of gx, okay. So this is basically an extension of the chain rule, or in other words, I like to call it our out and in rule. Remember that we've learned in the previous videos. Sorry, out and in rule. Actually, I wrote it wrong. Okay, out and in rule. Okay, so it's an out and in rule, by the way. Okay, so this is basically a derivative of the composite function. Now, if you were to do the integration, right, if you were to find the antiderivative of this particular this particular function right away, okay, it's actually pretty straightforward. Of course, we already know what the answer is really. It's just simply f derivative gx times with the g prime of x, okay, respect to dx would obviously give us f g x. Okay, that will be our answer. Of course, don't forget the plus c, the constant of integration. Okay, so that's a very simple answer. But normally, when we actually do the integration of this kind of functions, yeah, it's very tricky to actually do the integration. It's very, really tricky because where do you start? How do you integrate? And let me give you one example of this kind of function. Let's say we have a function, okay, that looks like this, right? Let's see. Let's give an example of a function. Let's say, for example, we have an integral, okay, of a composite function that looks something like this. So it's just 2x over x squared plus 5, right? Which looks like this, by the way. And we do not know how do we integrate or where do we start, okay? And here's a neat trick. For u-substitution, okay, what we would do is that we would take our u as gx, okay, for the general case, by the way, okay? So we take our u as gx. Of course, that would lead us to having our du over dx as g prime x, right? And we know that du is just equivalent to g prime x times dx. Okay, so what does that mean? All right, in the general sense, is that we can just simply get the integral of f prime u. Okay, f prime u du times uh du dx times dx, which of course gets cancelled out, just leaving us with the integral of f prime u du, which is a very simple integral to integrate actually. Then we just left with fu plus c. And then this u you can just replace it back and you'll end up having the original function, which will just be, okay, let me just draw an arrow real quick, will just simply be f gx plus c. Okay, so that's a very simplistic way, right, of actually how we use u-substitution, right? And let's actually go and solve the example problem right away. Okay, let me erase this real quick. Okay, all right. So first things first, for this function, I will actually take a u substitution here. I will just say this is equivalent to u. So u is equals to x squared plus 5. So my du dx is just 2x. So my du is just simply 2x times dx, which is perfect because our 2x times dx, we can write it as du. Okay, so if I rewrite the integration again, what will I end up having? I'll end up having du over u, which can be just equated to the integral of 1 over u with respect to du, with respect to u. So it's just simply ln u plus c. And we know our u is x squared plus 5, so just simply ln modulus x squared plus 5 plus c. So this is our answer basically. Okay, so for u substitution, the biggest trick, I would say, the biggest trick is to carefully choose the u. You need to be very creative, I would say, or I would say you need to be a little bit smart. So once you do enough practice problems, you'll be able to choose the right u, and you'll be able to immediately solve the integration, get a very simple integral, find the antiderivative, and voila, you get your final answer straight away. Okay, so let's do some practice questions. Okay, I'm gonna erase all of this and let's go for some practice question in the book. Okay, so let me take the book first. Okay. Okay. So the first problem we have is x, okay, root 1 plus x squared. Okay, actually let me write that question a bit more nicely. Okay. So the question actually in the book is asking you to find the integral of x times the root of 1 plus x squared dx. So how to find the integral to this question? So I'll let you guys pause the video for a while and try to find the integral, okay, via u substitution, to find the integration, the result by u substitution. And yeah, let's attempt it in a while. Okay, so assuming you guys have actually paused and tried to solve this problem, so let's do it together. First things first, if you realize that you can actually take this as your u, by the way, okay, you can substitute this as a u. And now why do I say we can take this as a result, 1 plus x squared? Because once you do the derivative du over dx, you end up having 2x, right? And du is just 2x times dx. Okay, and if you have noticed, by the way, in your integral, you have x times dx, but you don't have the 2. So how are you going to manage it? In this case, bring the 2 to that side, so it'll be half du equals to x dx. Okay, now your problem becomes much simpler. So therefore, your integral would be, it'll be the square root of u times half du. Now half is just a constant. You can just simply bring it outside, right? And then you're left with half integral u to the power of half with respect to u. So it's very straightforward. It's just half times u to the power of 3 over 2 over 3 over 2, right? Plus with c. And we know that our u is just 1 plus x squared, so it's just simply half times 2 over 3, and then you have 1 plus x squared to the power of 3 over 2 plus c, leaving u. Okay, you can of course cancel out the 2, right? It just becomes 1, right? Easily. So therefore you're left with 1 over 3, 1 plus x squared to the power of 3 over 2 plus c. So that is your final answer. Okay, pretty straightforward. Now let's go for a more interesting question. Okay, so okay, let's see. The next question here is this. So we have an integral, okay? It's basically the cosine of x times the sine cube of x, okay? Respect to dx. So they want to find the indefinite integral of this problem. So again, I'll give you guys the time to pause this video and try to find the answer to this question. Okay, so assuming that you guys have actually paused this video and tried to attempt it, let's go and solve the problem together. So first and foremost, um, if you're aware that the derivative of sine, okay, when you take the derivative of sine x, you already know the answer is cosine of x, right? So it is very logical. Yeah, we take our u, okay, as just sine x, okay, not sine cube x, sine x, because the derivative again is just simply a cosine, right? And we can rearrange it as the differential of u is equal to the cosine of x times the differential of x. So there you go. It's already aligned. The stars are aligned basically to us. Okay. Funny saying, but yeah. So now your integral becomes much simpler. Your integral simply becomes u cubed times du. And of course, as you solve it, it just simply becomes u to the power of 4 over 4 plus c. And then you substitute it back, it just becomes sine to the power of 4x over 4 plus c. So yeah, that's basically your answer. Pretty straightforward also. Now let's go for a slightly more interesting problem. Let me just erase this real quick. Okay. Now the question is given us this integral, okay? It's 2x plus 3 over x squared plus 3x plus 2, okay, dx, and they want us to find the indefinite integral to this problem. Okay, so I'll give you guys some time to pause this video and try to attempt this problem. Okay, so assuming you guys have actually paused and tried this problem, so it's a little bit interesting, but I think it's very similar to example problem, right? So of course, we will take our u to become x squared plus 3x plus 2, okay? And when we take the du dx, we end up having, surprise, 2x plus 3. Okay, which is a very neat result by the way. So du is just simply 2x plus 3 times with dx. It's a neat result because it's right there for us. It's ready-made. We don't have to do anything. Okay, so therefore our integral becomes much simpler. So it's an integral of du over u, which is just simply the integral of 1 over u du. And it's just simply ln modulus u plus c, which is left with ln modulus x squared plus 3x plus 2 plus c. Um, So here's the interesting thing also, what you can do is that if you want to make your results look a bit nicer, especially for logarithms, and I believe this one you could factorize it off. So it'll be ln modulus x plus 2 and x plus 1, okay, plus c. So x squared, x3x, and yeah, okay. So if you remember, if you have ln ab, you can just say it's just ln a plus ln b. So this is a rule of logarithms, by the way. It's like a common rule of logarithms. So from this rule, actually, right, you can simply rewrite your integral to be like this, just ln modulus x plus 2 plus ln modulus x plus 1 plus c. So this is your final answer. And let's say if you're not sure if this answer is right, what we can do is we can do a quick differentiation, okay? So let's just do the derivative, let's find the derivative of this, okay, real quick, so that we are sure that it's right. So let's do a derivative real quick. We'll end up having 1 over x plus 2 plus 1 over x plus 1. So of course we'd have here x plus 1, right, plus with x plus 2, okay, and you have here x plus 2, x plus 1, okay. I mean, we of course cross multiplied, right? We wanted to make sure that we get the same denominators right on both sides, okay. So yeah, just in case if you don't remember. So as we do it, okay, we'll end up having 2x plus 3, and we'll end up having our original equation, x squared plus 3x plus 2. So yep, it's proven that this answer is our it's already proved, okay? So this is proved actually. Alright, so you can make your answer a little bit more tidy like this by using the simple logarithm rule that if you have a ln of a times b, you can write it as just ln a plus ln b. Okay, so yeah, that's a very cool thing to remember. Let's go to another question. Okay, okay, let's see. Okay, we also have an indefinite integral, by the way. X over 1 plus x squared, I think, yeah, 1 plus x squared to the power of 2 dx. Again, find the indefinite integral of this, right? Try to solve it, and yeah, I'll give you guys to pause the video and give it a shot. Okay, so assuming you guys have actually paused the video and give it a shot, so let's do it together. First and foremost, it's quite, I would say it's a bit obvious that we'll take our u as 1 plus x squared, okay? Why we take it as 1 plus x squared, hear me out. Once we do the derivative, okay, so du dx, it just becomes 2x, okay? So du is just simply 2x times dx. But here's the problem, right? We have x dx, okay? And our du is just simply 2x dx. So what do? Of course, we bring the 2 to the other side, so we can actually tally it or we can actually match it. So half du is just x dx. So our integral will be far simpler. We're left with uh du, of course, over u times with half. So it just simply becomes, or by the way, u square, yeah? Don't forget the u square. I almost forgot about that. So this becomes half, okay, I put it to the outside, is just simply 1 over u squared with respect to du. And this can be written as half integral u to the power of negative 2 du, leaving us with half, okay, times u to the power of negative 1 over negative 1 plus c, okay, and as we simplify it back, it becomes negative 1 over 2 1 plus x squared to the power of -1. Okay, and plus c, which is just simply -1 over 2, 1 plus x squared plus c. Okay, so this is your final answer. And let's say if you are not so sure about it, again, do the differentiation in this case. So, of course, if you take the differentiation from this part, by the way, we're left with, so -1/2 is a constant, okay, times with -1. We're doing the very quick method of chain rule. So 1 plus x squared to the power of -2 times 2x. So of course that leaves it with what? You cancel the 2, you cancel the 2, you're left with 1. So you'll have negative, negative and negative become positive, by the way, so become positive x over 1 plus x squared to the power of 2. Of course, leaving us with x over 1 plus x squared to the power of 2. Okay, so this is your final answer if you proved it, right? Therefore, this is correct. Okay, so now let's go for another question. Okay, so let's see. We have another integral question, indefinite integral. So it becomes x over square root 4 minus x squared dx. Okay, so I'll give you guys time to pause the video and try to find the indefinite integral via u-substitution. Oops, sorry about that. Okay, so assuming that you guys have actually paused the video and give it a try, so let's do it together. First and foremost, so we find our u. So basically we take 4 minus x squared, okay, as our u. And it's very straightforward as to why we do this. So you get du dx is just -2x, and du is equals to -2x times dx. Right, you want to make sure that you want to get this out of the way. You want to get dx out of the way, right? But you have -2. So what we do with this -2, we take the -2 to this side. Of course, we bring it to the opposite side, becomes -1/2 du is equals to x times dx. So therefore integral becomes far simpler. It's just simply -1/2 du over square root of u, which we can of course take the constant outside, becomes -1/2 integral 1 over square root u du. Okay, and of course you can rewrite it like this as half integral u to the power of -1/2 du. Okay, leaving it with -1 over 2 u to the power of 1 over 2 over 1 over 2 plus c. So this -1/2 times 2 times u to the power of 1/2 plus c. Of course, this is very straightforward. We just leave it as 1. So therefore, it just simply becomes negative square root u plus c, which is obviously negative square root 4 minus x squared plus c. So this is your final answer. And again, if you want to double check and make sure it's correct, okay, just simplify the derivative of this. So of course, if you write it like negative for 4 minus x squared to the power of 1/2, right? And you want to find the derivative of this, right? So d dx, or let me just write it in square brackets. Okay, so what we end up having is just simply -1 over 2, 4 minus x squared to the power of -1/2 times -2x. So see the negative cancel out. We're left with what? We're left with if I were to erase this a little bit, if you don't mind, I'm going to erase this for the sake of space. We're left with uh we're left with what? We're left with this, right? We're left with x times 4 minus x squared to the power of negative half, right? Which is obviously x over square root 4 minus x squared. So therefore, the final answer that we've gotten earlier, which is just simply negative square root u plus c, and of course we're going back to negative square root 4 minus x squared plus c. This is the correct answer, by the way, okay? So we have already proved it. Alright, so now let's go for some definite integral questions. Okay, so let's see right here. Okay, okay. So we are given a definite integral, okay? So definite integral square root 3, 0, tan inverse x over 1 plus x squared dx. Okay. So now, um, we're asked to solve this, obviously, right? We're asked to find the answer to this problem. And this is a little bit tricky, actually. So let's work on this problem together. So the first problem is, what are you going to pick out u? Is it going to be 1 over 1 plus x squared, or is it going to be the inverse function? Let me just circle a different color. The inverse function. Which one is it? Right? Let's try with this 1 plus x squared. Let's try with it first. Okay. So I'm going to say that my u is obviously 1 plus x squared. Okay? So my du dx is 2x. So my du is just 2x times dx. Okay, but here's the problem. We don't see a 2x anywhere in the function itself, right? In this particular function, oh, sorry, let me choose a different color. Let me choose blue. Sorry. We don't see a 2x dx, right? We don't see a form. We don't see there is no 2x dx or x dx. We don't see this form at all. None. So that means choosing u to be 1 plus x squared is the wrong choice, okay? It's the wrong idea, alright? So therefore, let's now re-choose our u to be tan inverse, okay? Tan inverse x, okay? So what happens, okay, is that once we do the du over dx, okay, and for the inverse tan function, if I'm not mistaken, I decided to pull up my standard table, by the way, the one I shared last time in the previous video, which will also be shared in the description as well, in case if you didn't watch the previous video. Let me look for it. Where is this table? Okay. Okay. So if you take the derivative of it, by the way, is just simply the derivative of tan inverse is just simply 1 over 1 plus x squared. Let me just check with it again. So this is, yeah, basically 1 over 1 plus x squared. Okay. So our du is just simply dx over 1 plus x squared. Now here's the thing. If I use a different color, maybe I'll use white. Okay. I don't know if you have noticed, but if you rewrote the integral, okay, if you rewrote the integral, by the way, okay, so just pretend we wrote the integral, okay, or let me use a different, let me just rewrite it in a different, let me erase this, yeah, okay, because it's the wrong one, obviously. But if you rewrote the integral, if you rewrote the integral actually, what happens, or rewrite the function rather, okay, so we're going to write it, of course, with the same limits, square root 3 and 0. We'll have tan inverse x times, okay, 1 over 1 plus x squared times dx, okay? If you rewrite the integral like this, what we notice, okay, is that 1 over 1 plus x squared dx is equivalent to du, right? And this is just simply our u, and this is our du. So the integration becomes much simpler. Now here's one more thing just to remind you, by the way, when you're doing with definite integral, when you have limits, right? You will actually need to change those limits so that you'll be compatible when you're doing the integration. You actually save a lot of time, by the way. So if you rewrite the integration, yeah, let me write it in yellow just to make it clear. Okay, so we'll end up having our u du. So our limits now will be different, huh? So in this case, our u is hold up. Alright, let me just pull up my calculator just to make sure that we could get the answer. Okay, no, not this one. Let me see. And calc. Okay, perfect. So tan inverse of 0 is, well, it's 0. Okay. But for tan inverse of square root 3, it's okay if we do it by, let me just change the degree. Tan inverse of square root 3 would give me pi over 3. Right, would give me pi over 3. So of course you do the if you do the integration, it's just simply u square over 2, right? And then it's just simply pi over 3 and 0, alright? And if you simplify it, okay, what will happen is that, so let me clear this out, is that you'd have here, let me just write it, shift pi over 3 squared divided by 2 would give me, would give me pi squared, okay, pi squared over 18, okay, pi squared over 18 minus 0, leaving me with the answer of pi squared over 18. And if you wanted to find it in decimal form, it would be 0.5483. Okay, so 0.5483. Whichever answer you want to put, that's okay. But that's how we do it. Okay, so yeah, for functions like this, like if you have an inverse trig function and whatnot, you have to be very careful of choosing your u. So I just did a demonstration on that. And I think we can conclude with one last question of the day before we, finish this video. Right, so let me just erase this real quick. Okay. So we have the last integral of the day, and the integral is a definite one. The limits are between 4 and 1, and it's just simply e to the power of root x over root x dx, okay? So how are you going to solve this? Okay, you guys can pause the video if you want, but I'm gonna go and solve this problem. Alright, so let's look into it. First and foremost, what should we choose as our u? Okay, should our u be this one? Or should it be this one? Okay, so let's see. Let's say that my u is e to the power of root x. Okay, or we can simply write it as e to the power of x to the power of half. Okay, so how are we going to find the du dx? So we can write it in a different way. We can write as ln u equals ln e to the power of x to the power of half. Okay, and if you remember the power law of logarithms, yes, let's say for example you have a logarithm of a to the power of b just equals to b logarithm of a. So similarly, we're going to do the same here. So it become ln u is equivalent to, right? We're going to move the x to the power of half here. And we're going to have ln e. Now we know very well that ln e is just equivalent to 1, right? So therefore we'll have ln u is equals to x to the power of half. And of course we have to do implicit differentiation, right? So it'll be d dx, okay, of ln u equals to d dx times x to the power of half, okay? And once we do that, of course we'll have 1 over u times du dx is equivalent to, well, let's just say just 1 over 2 x to the power of negative half. And then we bring it back, we end up having du dx is just, well, let's just say it's just u is equals to u, okay, over 2 root x. And our u is e to the power of root x over 2 root x. Okay, that's our du dx. Okay, and that seems, I would say, fairly a bit complicated, but it can still be solved. So we can write it as what? We can write it as this, right? We can write it as du equals to half e to the power of root x over 2 to the power of root x dx. Okay? Sorry, it's not 2, my apologies. It's supposed to be e to the power of root x over root x. Okay? So, yes, it seems a little bit tricky. Okay? And of course, if you manipulate it a little bit further, we'll end up having 2 du is equals to e to the power of root x over root x dx. So that will simplify integral, okay? That will simplify integral a little bit funny. I would think we would probably simplify it like this. Oh, sorry. Let me see if we get the answer. No. So that would be, it'll just simply be 2 du. That's it. It'll be simply be 2 du. And our limits will change, by the way, okay? So we will end up having, since it's e to the power of root x, so e to the power of root 1 would just simply be e. And here would be e to the power of 2, or e squared technically, right? So we'll end up having what? We'll end up having 2u bracket e to the power of 2e, right? So it just simply become 2e squared minus 2e. Or we can just say just 2 bracket e squared minus e. Or actually, you know what? Never mind. We can just simply say it's just 2e, okay? Bracket e minus 1. Okay, that's much more nicer to look at. Okay, that's one way to do it. Now let's say I were to use a different u. Okay, so for instance, we don't use e to the power root x. Let's use a different one. Okay, so let's say our u is root x. Okay, or we can simply write x to the power of half. So our du dx is fairly straightforward. Our du dx is just, well, is just basically half x to the power of negative half, right? Which we can simply write it down as 1 over 2 root x. So you can write the du as just simply half times 1 over root x dx. And you bring that half to the other side, you'll have 2 du is equals to 1 over root x dx. Okay? And again, for this particular function, if you write it cleverly, it's just simply e to the power of root x times 1 over root x dx, right? Thus making a substitution a little bit easier, okay? And therefore your integral would just simply be e to the power of u, okay? And you would have times 2 du, and your limits would be between 1 and square root of 4 will obviously be 2, right? So the integration of e is very straightforward. So you're just left with 2 eu, okay, 2 and 1, okay, and you have 2e squared minus 2e, alright, which again would lead us to 2e is just simply e minus 1. So you end up getting the same answer regardless of which value of u you choose. But technically the one in orange is a little bit, I would say, a bit easier maybe. Okay, a bit easier is in the sense that it's not very difficult to differentiate and get the answer, whereas the first one we had to use implicit differentiation. Okay, we had to use a little bit of implicit differentiation, so it has some added complexity, I would say. But in the end of the day, you end up getting the same result. So this is basically the result. So it doesn't really matter which method you use, okay? Whether you stick to u as e to the power of root x, okay? Or whether we proceeded with sorry, let me just highlight orange. Um u to the power of root x, okay? It doesn't matter which substitution you use for this case, as long as you get the same answer. Though I'll prefer actually if we stick to this, okay? Because like I say, it's very easier in finding the derivative and of course substituting it in. It makes it so much easier to understand. Whereas for this one, we had to use implicit, which of course made it a little bit more complex, okay? And yeah, sometimes implicit differentiation might not work also, okay? So therefore, I rather suggest to stick with this one right away, okay? This is the better way to do the problem. Alright, so with that aside, we can actually end today's video. And the next video, we will be focusing more on trig substitution, okay? Basically, is an addition of u-substitution, but we're gonna talk about trigonometric substitution, okay? So this will be the next agenda of the video itself. So until then, I would say thanks for watching, okay? So thanks for watching actually. Right, so thank you for watching. Right, I forgot to write down. So thanks, and I'll see you in the next video.